Welcome everyone. In this video, we are going to prove that the square root of 2 is an irrational number. To start our proof, let's consider the definition of rationality. What does a rational number mean? Well, it simply means that a rational number can be written in the form, let's say it, k over p, where k and p are integers. These are elements of the set of all integers. This capital Z means the set of all integers. This means if you are able to write a number in terms of the division of two other integers, then that number is a rational number. Let me give you an example. 1 over 3 is a rational number because 1 is an integer, 3 is an integer, so we fulfilled the criteria. This means that for an irrational number, we simply cannot write it in terms of k divided by p, where k and p are integers. So what I want to ultimately show in this video is that the square root of 2 is not equal to k divided by p. But how can I do this? There might be other ways of doing this, but the way that I want to do it, which I believe is very elegant, is using a method called proof by contradiction. In proof by contradiction, we assume the statement that we want to prove or disprove. For example, I want to prove that this is correct, so I assume the opposite of this. I assume, and let me erase this arrow. I assume square root of 2 can be represented as the quotient of two integers. So it is equal to k over p. I make this assumption and I will do some calculations, some algebraic manipulation, and at the end I will arrive at a result. If that result does not make sense, if there is a contradiction in the result, I will say, hey, look, up to this point I did everything correct. Throughout the calculations, there was not a single mistake. Then the starting must be wrong because the final result doesn't make sense. This means the initial assumption was not correct. So I conclude that my assumption was wrong, which it would help us in our proof, because if I conclude this assumption is wrong, well then I got it. I proved that the square root of 2 is irrational. Okay? So we assume that square root of 2 is rational, we try to arrive at a contradiction, and when we do that, we conclude that square root of 2 is in fact not rational but irrational. So let's get started. And the way that I want to choose my k and p is a specific way. I want to have k and p that are co-primes. So k, p are co-primes. This doesn't necessarily mean that k and p are primes. This only means that they don't have a common factor besides 1, of course. So perhaps k is 7 and p is 12. 7 and 12 don't have a common divisor except 1, so we call them co-prime numbers. But let me erase this example because it was just an example. So with this in mind, let's start. I want to square both sides. Let's do that. I square the left, I square the right. When I square the left, what do I get? I get the square root of 2 squared, which is just by definition, 2. On the right, I will have k squared divided by p squared. If I multiply both sides by p squared, I get a formula for k squared. And that is k squared is equal to 2p squared. Look at this. For k squared, we have p squared times 2. If we multiply any number with 2, we get an even number. Okay, and remember, p is an integer, so its square is an integer. And if we multiply an integer with 2, we get an even number. This means this left side, the right side, is even. And of course, there is an equality, which means left should also be even. And if k squared is even, what can we conclude about k? We can conclude that k is also even. And if you don't believe me, I have a video about this. You can find it from the cards right now, also from the descriptions part. So we conclude that if k squared is even, then k must be even. Cool. And what does this mean? Well, this means that we can express k such that it is equal to 2 times n. N here is another integer. N is an element of the set of integers. Alright? Now we got this out of the way. Now what I want to do is, I want to substitute this 2n for k. Where should I substitute? Let's substitute it here perhaps, okay? So if I do that, I substitute it, so I have, let's continue with green. I will have 2 is equal to, instead of k squared, I will write 2n squared. So I will simply get 4n squared divided by p squared. So if I again multiply both sides by p squared, I will get 2p squared is equal to 4n squared. If I simplify by 2, I get a familiar looking picture, don't I? I get p squared is equal to 2n squared. What does this mean? This means that p squared is an even number because, again, look at this. On the right, we have something even because we multiply an integer with 2 and that makes it even. And since we have an equality, right and left should be equal. This means p squared is also even. And if p squared is even, what can we say? We can say that p is also even. And look at this. What is the bottom line here? What is the main idea? We started off by saying k and p are co-primes. However, at the end we found the result that k is even and p is even. Two even numbers cannot be co-primes of one another because by definition both of them are divisible by 2. Right? We define co-primes as the numbers that don't have a common divisor except 1. But if we have two even numbers, they are automatically not co-primes because both of them are divisible by 2. This means we arrived at a contradiction. It is a contradiction that k and p are both even and that they are co-primes of one another. That cannot be correct. That is a contradiction. But we did everything right along the way. Every single step was correct. How can the final result be wrong? Well, that means the initial assumption was wrong. This assumption was wrong. This is debunked, which means square root of 2 is not equal to k over p. And that is, look at this, that is exactly what we hoped to prove. So, in short, we were able to show that square root of 2 is an irrational number because we assumed it otherwise and did some calculations. At the end, we arrived at a contradiction and concluded that our assumption was wrong. I hope this video was helpful. If you have any questions, please write them in the comment section. I hope to see you in another video. Until then, take care.